You were probably taught that the center of a black hole is an infinitely dense point. Here is the honest truth. That point is the least trusted object in physics. The edge of a black hole? Photographed. The fall through it? Calculated in detail. But the center is where our best theory of gravity stops giving answers, and physicists are now seriously trying to delete it. So let's take the trip inward and keep score of exactly where the knowledge runs out.
Start with what is solid. This ring of light is a real image of a black hole, M87 star, 6.5 billion times the mass of our sun, at the heart of a galaxy 55 million light-years away. To capture it, astronomers linked radio telescopes on 4 continents into one virtual dish the size of Earth. And in 2019, they released this picture. In 2022, the same network imaged the black hole at the center of our own galaxy. And one detail makes these images more than portraits. General relativity predicted the size of both rings in advance and got both right, across 2 black holes more than 1,000 times apart in mass.
But be precise about what you are seeing. The glow is not the black hole. It is hot gas orbiting just outside, its light bent into a ring by gravity. The dark middle is the shadow, the region where light falls in and does not come back. The true point of no return, the event horizon, hides inside that darkness, smaller than the shadow itself. By 2024, the network could even map the magnetic field spiraling at the edge of our galaxy's black hole. So we can see the doorstep in remarkable detail. No one has ever seen past it. The journey inward begins at that doorstep, and it starts with 2 corrections. First, black holes are not cosmic vacuum cleaners. Swap our sun for a black hole of the same mass, and Earth would not get pulled in. It would keep orbiting exactly as before, just in the dark. Because at a distance, gravity only cares about mass. Second, the horizon is not a wall. There is no surface there, nothing to hit, nothing to feel. It is a one-way line drawn in space-time itself. Outside the line, light can still climb away. Inside it, every possible path, for light, for matter, for you, bends toward the center. Which leads to the eerie part. If the black hole is big enough, crossing that line feels like nothing at all. No jolt, no flash, no warning. You are simply in free fall, watching the stars at your back. Physicists call it no drama. But the moment you drift past the horizon, your future is already decided. Every path you could steer along now ends at the center. Escape is not difficult from in there. It is that out no longer exists as a direction. Whether you even survive the crossing depends on a fact most people have backwards. Small black holes are deadlier at the edge than giant ones. The danger is stretching. Your feet, slightly closer to the center, get pulled harder than your head. Near a black hole of 10 solar masses, its horizon barely 60 kilometers across, that difference climbs to tens of millions of G. You would be drawn into a thin strand before you ever reached the horizon. Spaghettification is real tidal physics. But at the horizon of our galaxy's black hole, 4 million suns, 24 million kilometers across, the difference across your body is about 1/10,000th of a G. You would not feel it. The bigger the black hole, the gentler its edge. The stretching is not canceled, though. It is postponed, moved deep inside, where no path leads back out. So you fall on, intact, into a place no observation has ever reached. And this is where the confidence meter starts to drop. Einstein's equations still work in here. They describe the curvature climbing faster and faster all the way down. But at the very center, they make their most infamous prediction. Everything that ever fell in crushed into a point of zero size and infinite density. A singularity. And this is no rounding error. In 1965, Roger Penrose proved that once collapse passes a point of no return, general relativity cannot avoid creating a singularity. No lucky wobble, no off-center spin prevents it. That proof won the Nobel Prize in 2020.
Here is what the textbook version usually skips. Most physicists do not believe that infinity is physically there. When a theory starts outputting infinities, that usually means it has been pushed past its limits. General relativity knows nothing about quantum mechanics, and a black hole's center is exactly where quantum effects should take over. So read Penrose's theorem with honest eyes, and it says something stranger than there is a dot of infinite density. It says push general relativity far enough, and it predicts its own breakdown. The singularity is not the thing inside a black hole, it is the place where our map tears. That is why theorists are now building black holes with no singularity at all. In February 2025, a team in Barcelona showed that adding an infinite tower of small corrections to Einstein's equations, corrections from gravity itself, no exotic matter, can smooth the center into a finite, well-behaved core, at least in their higher dimensional models. A rival approach, loop quantum gravity, argues space itself cannot be squeezed below a smallest scale, so collapse would slam into that floor and bounce. And some physicists ask whether a few black holes might be mimickers, exotic objects with no true horizon at all. None of these is confirmed. All are serious attempts at what really sits where the map tears. And the referee will be data. Sharper images of those rings and gravitational waves from black holes colliding.
And even if one of those ideas fixes the center, black holes hide one more problem, maybe the deepest in physics. In the 1970s, Stephen Hawking showed that quantum effects at the horizon make every black hole glow, impossibly faintly, and slowly lose mass. Left alone long enough, it evaporates completely. For a black hole with the sun's mass, that takes 10 to the 67 years, a 1 followed by 67 zeros. But that faint glow looks perfectly random, carrying no trace of anything that fell in. If the black hole then vanishes, the information about everything it ever swallowed is destroyed. And quantum mechanics is built on the rule that information can never be destroyed. This is the information paradox, our theory of gravity and our theory of matter in open contradiction. Recent calculations hint the information does leak out, hidden in subtle patterns in the glow. One proposal from just weeks ago even suggests evaporation stops at the last moment, leaving a tiny remnant that stores it. That one is openly speculative. The fight is not settled.
So here is the honest scorecard. The edge of a black hole? Photographed, and matching prediction across a 1,000-fold range of masses. The crossing? Well understood physics. Gentle at a giant's horizon, lethal near a small one. The singularity? A bulletproof prediction of classical general relativity. The actual center? Unknown. Probably not an infinitely dense point. Possibly a quantum core, a bounce, or something nobody has written down yet. That blank on the map is not a failure. It is the most precisely located mystery in science. The one place in the universe where we know for certain that our current physics is not the final word.